All right, with number 71, what you got to do is you have to get the bases to be the same, right? 4 and 16 share a common base, which is 4, so I can say 4 to the 2x plus 5 is equal to, 16 is really 4 squared, right? So 4 squared to the x plus 1, right? Now from here I'm going to go and distribute my exponents in, so this is going to be 4 to the 2x plus 2 is equal to 4 to the 2x plus 5. Now, because my bases are the same, that means my exponents are the same. So that means that I really have a problem of 2x plus 5 is equal to 2x plus 2. Well, I'm going to subtract 2x from both sides, and I get 5 equals 2. Well, that's never true, which means that this is no solution. All right? So your number 78. Log base 3 of rad 9. Okay, let's take a look. What is the square root of 9? You have 3. So it's going to be log base 3 of 3. Now, whenever I have a log that has the base and the answer being the same, what is the exponent that creates that solution? Dumb. 1. I believe there was a problem actually like that on the quiz where it was like log base 7 of rad 49 or something like that, and the answer was 1 also. I don't know. Something to kind of keep an eye on. All right, let's do the next one here. We just did 71 and 78, so 98. 98, 98, 98. Okay. Wait, I thought we did 98 yesterday. Yeah. Yeah, check yesterday's video. Sorry. 101. Okay. Oops. Log base 8 of 48 minus log base 8 of 16 over 5 plus log base 8 of 5 is equal to log base 8 of 5x. Okay, so what I have here is I have a bunch of different things going on here. I have log base 8 minus all of this stuff, okay? So what I'm going to do is I'm going to combine all three of these logarithms. The first set of logarithms, actually no, let's see if we can't condense it all into one solid logarithm here. Does it make sense that I really have 48 divided by 16 over 5 times 5? Does that make sense? Right? So what that really means is since order of operations is going to move from left to right, and let's not forget all that equals log base 8 of 5x, order of operations moves left to right in division and multiplication. So I'm going to flop this, this division sign, so it's going to be 48 times 5 over 16 times 5, right? And that's log base 8 of that, and that's equal to log base 8 of 5x. So 48 divided by 16 is 3. 5 times 5 is 25 times 3. 25 times 3, where are my Chuck E. Cheese employees? 75. Log base 8 of 75 equals log base 8 of 5x. Now that I have a single logarithm on both sides, what can I do with those logarithms? Chris? Or rather this, right? Set the answers equal to each other, right? So what does x equal? What's 75 divided by 5? Ty? 15. All right? That's a good problem. Really tests some algebraic skills right there. All right, that was 101. Good question. 150 rather. Okay, we're trying to find the sum of the arithmetic series. So let me see here. 3 plus 12 plus 21 plus 30 plus 57. Okay, in order to do this, we need a formula. Since it's an arithmetic series, since it told me it's going to be S sub n is equal to n over 2 times a sub 1 plus, a sub n. All right, well, a sub 1 is 3. A sub n is equal to 57. So I could say S sub n is equal to n over 2 times 3 plus 57. I need n though. How do I find n? How do I find n in this problem? Gabby? No? No, I wish there was a formula out there that would allow me to find n really easily. Michael, what do you think? We got to use the sequence formula, which is a sub n equals a sub 1 plus n minus 1 times d. Now the thing is, we still don't have d, but we can find out what d is. What is d in this whole sequence? If we were to see it as a sequence, what is d? Ty? 9. So we can say now that 57 is equal to 3 plus n minus 1 times 9. Whoops, I don't need that n bracket there. So from here, I'm going to go ahead and subtract 3 from both sides. So I've got 54 equals n minus 1 times 9. Now I'm going to do something a little bit different. I'm going to divide by 9. So I get, if I scroll this thing down, I get n minus 1 equals 6. Therefore, n equals 7. Now that I've found n, I can pump that into here. So let's go ahead and erase this and put a 7. That makes the problem a little more manageable. So S sub 7 is going to be 7 over 2 times 60. Those are going to go away. You get a 30. So what does S sub 7 equal? 215. 210. 210. Okay. Formulas. Lots. This is probably the most formula-intensive midterm you guys are going to have. Actually, no, that's not true. Conic section is pretty formula-intensive. Remember those? Those are coming back in, 5 or 6 weeks. That was 150, 164. Find S sub n for the geometric series. A sub 1, oops, darn it. 164 is A sub 1 equals 1 over 81, R equals 3, N equals 6. Okay, so let's just check out the formula that we need. We need to find the geometric sum, so that's going to be S sub 6 is equal to A sub, not S sub, let's get the general formula down, S sub n equals A sub 1 times 1 minus R to the n, all over 1 minus R. I believe we have all the information we need. It's 1 over 81, we have an A sub 1, we have an R, we have a 6. Okay, we're good. So now we just need to pump this thing into the formula and then be done with it. So it's going to be S sub 6 is going to equal A sub 1, which is 1 over 81, times 1 minus R, 3 to the 6th, all over 1 minus 3. Now, this is negative 2. That's easy. I need 3 to the 6th power, please. Who can give us 3 to the 6th power? 729. 1 minus 729 is negative 728. Can someone take negative 728 and divide it by 81? You're not going to get a clean number, I know that. No? Okay, forget it. Alright, so now what we're going to do is we're going to multiply this negative 728 over 81 times 2, negative 2. So I need negative 728 times 2, or 728 times 2. Excited? 1456. Well, it should be positive, right, because two negatives multiply together. 1456 over 81. Okay. That was 164. I passed over 144. I will get back to that, Sean. Looks like 194 is the second to last. What are we? 194? Ah! Okay, we're trying to find the fifth term of x over 2 minus 3y to the 8th. Now for this, we need a binomial expansion formula. So that is going to be summation from k equals 0 to n of n factorial over n minus k factorial times k factorial times a to the n minus k and then b to the k. This is that binomial expansion formula you guys are supposed to remember. Okay, if they ask you for the fifth term, there are only two things you really need to understand, n and k. N should be 8 because it's always equal to the exponent they're asking. Anyone remember what k is? Alan? 4. 1 less than the term they're asking for, so k equals 4. So now we've got to pump this thing into the formula. So this is going to be summation from k equals 0 to n, which is 8, n factorial, which is 8 factorial, over n minus k, so 8 minus 4 factorial, k factorial. And that's all going to be multiplied by a, and a is going to be x over 2 to the n minus k, so that's 4, and then 3y to the k, and 3y should be negative. Alright, so let's go and expand all this stuff out. I'm going to clean this up a little bit here. I got to get rid of this little thing. Alright, so 8 factorial is really, let's see, summation, oops, not infinity, k equals 0 to 8. So this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 8 minus 4 is 4, so that's 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. And that's all being multiplied by x over 2 to the 4th, and this is negative 3y to the 4th. Alright, let's start canceling some things out. 4, 3, 2, 1, 4, 3, 2, 1. Okay, here's where things are going to start getting a little messy. Does it make sense that 3 times 2 is 6? Yes? Okay. 8 and 4 can cancel, leaving me with a 2 up top. Let's see here. 10 times 7 is 70. So the term should be 70. Looks like x to the 4th over 16 times, looks like 81y to the 4th. All I need is 70 times 81. Or actually, we can reduce that. If I divide those by 2, I get a 35 and I get an 8. So I need 35 times 81. 2835. 81 times 35. 2835. Oops. 35. X to the 4th, y to the 4th, all over 8. So that is your fifth term of that. Yeah? Okay, good. 144 now. 144. Let's jump backwards. Write an equation for the nth term of the geometric sequence. Okay. Okay, so a sub 1 is equal to 3. Everyone okay with that? D is equal to 2. Okay, so Sean, remember when we were doing this in the very beginning when we had it was like 3. So a sub 1 was 3, right? Put this up. A sub 1 was 3, right? A sub 2 was 5, but we said 3 plus 2, right? Yeah. And then a sub 3 was 3 plus 2 plus 2, but we had a different way of writing 3 plus 2 plus 2. It was 3 plus 2 times 2. And then a sub 4 was 3 plus 2 times 3. Do you remember when we were deriving this from something? Okay. So what was a sub, let's say a sub 99. 3 plus 2 times what? 98. So then a sub n would be 3 plus 2 times, what was the connection here every single time? N minus 1. Where 3 is a sub 1, 2 is the distance, and then n minus 1 is your thing. That's how you do it. Okay? Alright. Let's go and pause there for a second. 56. We are subtracting two fractions that don't have the same denominator, so we need to get a common denominator. Before we do that, we're going to factor the denominators out. So it's going to be x minus 4 over x, looks like plus 4, and then x minus 2 minus x plus 2 over x plus 4 times x minus 4. Okay, so it looks like our common denominator here is going to be x plus 4 times x minus 4 times x minus 2. Remember, I only need one x plus 4 because each term only has one of them. So now I got to multiply by what's missing. This one's missing an x minus 4. This one's missing, looks like an x minus 2. Okay, let's go and multiply this out. Let's see here. This is going to be, well, this is a perfect square trinomial, so this is x squared minus 8x plus 16 minus. Now, remember, this is an entire quantity because I'm foiling it. So it's going to be conjugates, so x squared minus 4. Cameron, I have a funny feeling this is where the mistake happened. Right? And that is very, very typical. Don't worry about it. It happens. Remember, you are always subtracting the entire thing, not just one thing. So this is going to become negative x squared plus 4, which means the x squareds are going to cancel each other out. 16 plus 4 is 20, and then negative 8x comes along for the ride, and then you get your common denominator, x plus 4, x minus 4, and then x minus 2. Now, let me see what would happen here. If I factored out a 4, it won't help me, so forget it. You're done. Okay. So Cameron, yeah, you dropped the brackets. No problem. I have been guilty of that, actually, just a couple weeks ago, so no worries on my end. All right. Thank goodness for undo. Oops. All right, number 81. 81. What is it? Log base 36 of 6. So we're asking us 36 to the what power equals 6? Well, how can I move from 36 to 6 using exponents? What, or some kind of like symbol? Alan, what do you think? Fractions. All right, fractions. So the box has to equal what fraction will bring 36 down to 6? Alan, 1/2. Or you could have said that the square root of 36 is equal to 6 because, Max, 36 to the 1/2 and rad 36 is the same thing. Good job, dude. Max, that's going to live on in memory even after you are done with this class. 56 is done. 81 is done. We are now on 87. Teacher Joseph, this is your question, right? Not as obvious as putting ice cream in the freezer, right, Teacher Joseph? Not as obvious. Okay. All right. This is a multi-layered logarithm. This is like the inception of logarithm problems. Look, we have to change forms here because we're stuck. 5 to the 0. I know we did this before. I like this problem, so we're going to do it again. 5 to the 0 equals log base 3 of x. 5 to the 0 is 1, so 1 equals log base 3 of x. We're stuck again. Change forms again. 3 to the 1 equals x. 3 to the 1 is 3, so you're done. I like that problem. Inception. That was 87, 90. Okay. 90. Log base 9 of x squared minus 9x equals log base 9 of 10. Okay. You have a... Cameron. Oh, thank you. If you have a single logarithm of the same base on both sides, those logarithms are single. They are isolated, and they equal each other, you get rid of them. Bam. So you get x squared plus 9x equals 10. X squared plus 9x minus 10 equals 0. So it looks like x plus 10 times x minus 1 is the answer, or rather is the factor. So x equals negative 10 and 1. Is there anything in here that will not work? Negative 10? Negative 10 won't work. It will work? Why will negative 10 work? Because it's being squared. Very good. Very good. The x squared allows it to be negative. Good. Chief, is that what you said? Good man. All right. Got to be careful. I don't want to cross off an answer that actually was legit. All right, so that was 99. Oh, that was 90? 99. Ah. Okay. Use your properties of logarithms. Back this thing in there. This is log base 6 of x equals log base 6 of 9 to the 3/2 plus log base 6 of 2. What is 9 to the 3/2 power? Whenever we have fractional exponents, we always root it down first. So what is the second root of 9? What is the second root of 9? Yemsi. 3. Yemsi, what is 3 to the third power? 27. So this is log base 6 of 27 plus log base 6 of 2 is equal to log base 6 of x. Now, I'm going to do this, right? X equals 29? No! What do I do next? Chief, what do I do next? Multiply 27 times 2. So I have a single logarithm of 6 of 54 equals log base 6 of x. Now, what can I do, Chief? Now they can go away. Chief, what does x equal? 54. Done and done. Right? Aren't I cool? $130. Ah, yes. Alyssa deposits $1,550 into a bank account where it's compounded continuously. The interest rate is 7.25%. How much money will Alyssa have after 8 years? Okay. You know what? Let me pause this real quick. Okay, now that we have it all typed out. Okay, what type of problem is this? Growth and decay problem. So we need to identify our pieces. Yes. Oh, sorry. Thank you. All right, everybody. Okay, Alyssa deposits $1,550 into a bank account. What letter is the $1,550? P, right? That's the initial amount of money she puts in. The interest rate is 7.25%. That means that this 725 is going to appear under R. Where people are going to make their mistake, though, is they're going to put it in as 7.25 as R. But that needs to be converted into a decimal. What is 7.25% as a decimal, Nate? 0.0725. What is E? E. T is what? 8. What are we trying to find? A. How much money she's going to have. So A equals P. Oops, what am I doing? P is 1,550. E to the 0.0725 times 8. Okay, people, in your calculators, go 0.0725 times 8, then raise E to that. All right, just do the first calculation. Multiply the two numbers. Chief, what did you get? 0.58. Okay, don't round off. Go E to that power. Don, what'd you get? Give me E to the thing. Is this old man really faster on a calculator than you guys are? And then E to that answer, boom. Okay, so this whole thing becomes 1.786038 blah 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 blah. Now I'm going to take this answer and multiply it by 1550. 2768.35. Actually 0.36, she gets an extra penny. Lucky her. Save a penny, it's good luck. Alright, that was 130, 153 now. Those compound interest formulas should be pretty easy at this point. 153. Okay, write the terms of the arithmetic sequence, or the series. So summation from n equals 1 to 6 of n plus 2. Okay, since they're asking to write out the terms, you actually have to muscle through and do it. So when you get n equals 1, you're going to get 1 plus 2. When you get n equals 2, you're going to get 2 plus 2. N equals 3, you're going to get 3 plus 2. N equals 4, 4 plus 2. N equals 5, 5 plus 2. N equals 6, 6 plus 2. Each of these numbers is going to become 3, 4, 5, 6, 7, 8. And now you have to add those numbers together. 3 plus 4, 7, 14, 25, 33? Oops. 188. Last one. Oh, wow. Expand the binomials. Okay. Let's see here. What time do we get out of here? 21? Okay, this is going to take us too long. I'll do it at lunch. Alright, here comes number 188. We're trying to expand x minus y to the 7th power. This is the row of coefficients on the Pascal's triangle. You can come in, it's fine. And so each term is going to get an x and a negative y. So x and a negative y, and I get an x and a negative y, x, negative y, x, negative y, x, negative y, and I don't want to bore you with any more. I'll just pause it. That won't. And then x and negative y. Darn it, out of space. Okay, each one is going to get an exponent, so the first term always starts high and goes low. So 7, 6, 5, 4, 3, 2, 1, and 0. The y terms are going to start low and go high, so this is going to be 0, 1, 2, 3, 4, 5, 6, and 7. Hey, Ling, give me a second, okay? Give me 1 second. X to the 7th is what you're going to get. And then this is going to be 7x to the 6th and a y. This is going to be negative. This is going to be 21x to the 5th, y squared. 35x to the 4th, y to the 3rd. 35x to the 3rd, y to the 4th. 21x squared, y to the 5th. Boy. 7x, y to the 6th, and then y to the 7th. Now, because it was x minus y and the first symbol was negative, it's going to go positive, negative, positive, negative, positive, and lastly, negative. So this whole row is your answer from here all the way, and then I got to scroll over again, all the way over is what you're going to end up with. That is a long problem. Okay? All right.